Assalamu alaikum. This is Dr. Hamed Mohammed Almantheri, and today I will introduce and explain iteration in Python to you. So, what is iteration or repetition? Iteration is a fundamental concept in programming, allowing repetitive execution of code blocks. It enhances efficiency by automating repetitive tasks, reducing manual errors. Common iteration structures include loops like for, while, and do while, each serving specific use cases. Mastery of iteration is crucial for optimizing algorithms and improving code performance. Iteration involves executing a set of statements repeatedly. Python simplifies this with features like loops. There are two types: definite iteration, where repetitions are predetermined, such as with a for loop, and indefinite iteration, where repetitions depend on a condition, like a while loop. Iteration involves executing a set of statements repeatedly. Python simplifies this with features like definite iteration, where the number of repetitions is predetermined, such as with a for loop. And definite iteration occurs when a code block executes repeatedly until a specific condition is met. This is exemplified by the while loop, which continues to run as long as the condition remains true. Unlike definite iteration, the number of repetitions isn't predetermined, allowing for more dynamic control over the execution flow. The while loop is a fundamental control structure in programming. It repeatedly executes a block of code as long as a specified condition remains true. This allows for efficient handling of tasks that require repeated actions until a certain state is achieved, making it essential for tasks like data processing and iterative calculations. The while loop statement enables continuous execution of a code block while a specified condition remains true. This loop is essential for tasks requiring repeated actions until a particular criterion is met, ensuring efficient and dynamic programming. The syntax of a while loop begins with the keyword while, followed by a test condition in parentheses. If the condition evaluates to true, the loop's body, which is indented, executes. This process repeats until the condition becomes false, ensuring efficient control flow in programming. The while loop begins by evaluating the test condition. If true, the loop's body executes. Indentation is crucial to define the loop's body. After execution, the condition is re-evaluated. This cycle repeats until the condition is false, ensuring controlled iteration based on the test expression. The loop's body executes only if the test condition is true. After each iteration, the condition is re-evaluated. This cycle repeats until the condition is false. The loop's body begins with indentation, and the first unindented line signifies its end. In Python, the while loops evaluates to true for any non-zero number, allowing the loop to execute. Conversely, none and zero are interpreted as false, terminating the loop. This understanding is crucial for controlling loop execution effectively. To print numbers from 1 to 5 using a while loop, initialize a variable, say I, to 1. Use while I less than or equal to 5 as the condition. Inside the loop, print I and increment it by 1 using I plus equals 1. This loop continues until I exceeds 5, effectively printing numbers 1 through 5. Consider a while loop that prints even numbers from 2 to 10. Initialize a variable at 2, and while it is less than or equal to 10, print the variable and increment it by 2. This loop efficiently demonstrates how to iterate over a specific range with a defined step. A while loop can efficiently manage countdowns. Consider a program that starts at 5 and decrements by 1 until it reaches 1. The loop checks if the current number is greater than 0, executing the block to print the number and decrease it by 1, ensuring a smooth countdown. Let's explore another example of a while loop. Consider a program that calculates the factorial of a number. The loop continues multiplying the current number by the decrementing counter until it reaches 1, effectively computing the factorial. This demonstrates the power of while loops in handling repetitive tasks efficiently. The while loop is a fundamental control structure in programming, allowing repeated execution of a block of code as long as a specified condition is true. For example, a while loop can iterate through numbers, checking conditions or performing calculations until a certain criterion is met, such as reaching a sum or finding a specific value. To find the sum of numbers from 1 to 10, use a loop to iterate through each number, adding it to a cumulative total. Initialize a variable to store the sum, then incrementally add each number from 1 to 10. This results in a total sum of 55. To calculate the average of three numbers, prompt the user for input, sum the numbers, and divide by 3. For factorials, use a loop to multiply a sequence of descending integers. For example, 5 factorial equals 5 times, 4 times, 3 times, 2 times 1, 1, resulting in 120. To calculate the average of n numbers, first prompt the user for n, the number of values. Then collect these numbers from the user. Sum the numbers and divide by n to find the average. This approach allows flexibility in handling any number of inputs, enhancing the program's utility.
To calculate the average of n numbers, first prompt the user to input the value of n, then collect n numbers from the user. Sum these numbers and divide the total by n to find the average. This method ensures accurate computation of the average for any given set of numbers. In Python, a while loop repeatedly executes a block of code as long as a specified condition is true. This is useful for tasks that require repeated actions until a certain condition is met. For example, checking if a student's score is above 50 to determine if they passed or failed a course. In Python, use a while loop to input final marks for 4 students. For each student, check if the score is above 50. If true, print you passed, otherwise print you failed. This exercise helps in understanding conditionals and loops in programming. To calculate the discounted price of products, first determine if the price exceeds 50 Omani Rial. If it does, apply a 40% discount. Otherwise, apply a 20% discount. Use the formula discounted price equals product price minus product price times discount percentage. This ensures accurate pricing for each of the 3 products. To calculate discounted prices in Python, input 3 product prices. If a price exceeds 50 Omani Rial, apply a 40% discount. Otherwise, apply 20%. Use the formula discounted price equals product price minus product price times discount percentage. This ensures accurate pricing adjustments based on the initial cost. An infinite loop continuously executes without termination. This occurs when the loop's condition always evaluates to true, such as using while true. Infinite loops can be useful in scenarios like server processes, but must be managed carefully to avoid resource exhaustion. An infinite loop continuously executes without termination. This occurs when the logical expression in a while statement is always true, such as using the constant true. Understanding infinite loops is crucial for debugging and optimizing code efficiency. Infinite loops can occur when the loop's condition is always true, causing the loop to execute indefinitely. This often results from a logical error, such as a missing update statement or incorrect condition. Understanding the causes of infinite loops is crucial for debugging and ensuring efficient program execution. Infinite loops occur when a loop's exit condition is never met. For example, a while loop with a condition that always evaluates to true will run indefinitely. Another example is a for loop with no increment statement, causing it to repeat endlessly. These loops can cause programs to freeze or crash if not handled properly. Infinite loops occur when a loop continues indefinitely due to a condition that never becomes false. They can cause programs to freeze or crash. Common examples include while loops with conditions that are always true. Understanding how to prevent infinite loops is crucial for efficient programming. The for loop is ideal for iterating over a list of items. It allows us to construct a definite loop using a for statement, efficiently processing each element in the list. This ensures that every item is accessed and manipulated as needed, providing a structured approach to handling sequences. The syntax of a for loop involves iterating over a sequence with for val in sequence. Here, val represents each item in the sequence. The loop continues until the last item is reached. Indentation is crucial to separate the loop's body from the rest of the code, ensuring proper execution. A flowchart of a for loop using the range function illustrates the process. It starts with initializing the loop variable, checks the condition, executes the loop body, and updates the variable. This cycle repeats until the condition is false, effectively iterating over a sequence of numbers generated by range. The range function is essential for looping a specific number of times. It generates a sequence of numbers with syntax options: range end, range start, end, and range start, end, step size. By default, the start is 0 and the step size is 1, incrementing by 1. For example, range 1 to 10, 2 produces numbers from 1 to 10, 9, stepping by 2. Using the range function in a for loop, the sequence ends at end minus 1. For example, range 6 generates numbers 0 to 5. With a specified start and step size, like range 1, 10, 2, it produces 1, 3, 5, 7, 9. This flexibility allows precise control over iteration sequences. Using range 1 to 6 generates numbers 1 through 5. Similarly, range 5 produces numbers from 50 to 4. These functions are essential for iterating over sequences efficiently, allowing precise control over start and end points in loops. Using the range function, we can generate sequences of numbers. For example, range 2 to 6 produces 2, 3, 4, 5. Similarly, range 10 to 1 minus 2 generates 10, 8, 6, 4, 2. These sequences are useful in loops, such as printing numbers from 0 to 4 or 3 to 6. Using a for loop, you can print numbers in a specific range. For instance, to print numbers from 5 to 1, use range 5 to 0 minus 1. This iterates backwards, decrementing by 1 each time. Similarly, to print numbers from 10 to 50, incrementing by 10, use range 10 to 51, 10. To print numbers from 5 to 1 using a for loop, iterate with a decrementing step. For example, for I in range 5 to 0, step minus 1, print I. To print numbers from 10 to 50, incrementing by 10, use for I in range 10 to 50, incrementing by 10, print I. These loops efficiently handle repetitive tasks. While loops are fundamental in programming, allowing repeated execution of code blocks, they continue until a specified condition is false. For example, a while loop can print numbers from 1 to 5 by incrementing a counter variable. This control structure is essential for tasks requiring repeated actions based on dynamic conditions. Loops can incorporate conditional checks within their bodies, such as if-else, or if-elif statements. For instance, to print numbers ending with 5 between 1 and 50, a loop can iterate through numbers using a condition to check if the number modulo 10 equals 5, ensuring only the desired numbers are printed. Consider a list of numbers. Using loops with conditions, we can filter numbers ending with 5. This involves iterating through the list and applying a condition to check if the number modulo 10 equals 5, effectively isolating the desired numbers. The break statement is crucial for controlling loop execution. It allows you to exit a loop prematurely, regardless of whether the loop's condition is still true or if the sequence is fully iterated. This is particularly useful for optimizing performance and managing complex loop conditions efficiently. The break statement interrupts a loop's execution, halting it immediately. This occurs even if the loop's condition remains true in a while loop, or if a for loop hasn't iterated through all items. It's a crucial tool for controlling loop flow efficiently. The break statement is crucial for controlling loop execution. It allows you to exit a loop prematurely, regardless of the loop's condition. This is particularly useful in scenarios where you need to stop processing based on a specific condition, enhancing efficiency and control in your code.
To continuously take user input until done is typed, use a loop with the condition set to true. This ensures the loop runs indefinitely, only stopping when the break statement is encountered upon the user entering done. This approach efficiently handles user input in a controlled manner.
To print numbers from 5 to 1 and terminate at 2, use a loop with a break statement. Start the loop at 5, decrement each iteration, and include a condition to break when the number equals 2. This ensures the loop stops before printing 2, effectively demonstrating controlled termination. In programming, the break statement is crucial for controlling loops. It allows you to exit a loop prematurely when a specific condition is met. For instance, when printing numbers from 5 to 1, using break at 2 stops the loop, preventing further execution. This technique is essential for optimizing code efficiency and managing loop behavior effectively. The break statement in Python is used to exit a loop prematurely. When encountered, it stops the current loop iteration and transfers control to the statement immediately following the loop. This is particularly useful for terminating loops based on a specific condition, enhancing control flow within your code. The continue statement in Python allows the program to skip the remaining code in the current loop iteration and proceed directly to the next iteration. This is particularly useful for controlling loop execution and optimizing performance by bypassing unnecessary operations.
The continue statement disrupts the current loop iteration, allowing the program to skip remaining code and return to the loop's start for the next iteration. This is useful for bypassing specific conditions without exiting the loop entirely, ensuring efficient loop control and execution. A flowchart for the continue statement visually represents its function in loops. When continue is encountered, the current loop iteration halts, and control returns to the loop start for the next iteration. This ensures the loop continues without executing the remaining code in the current iteration. Wassalamu alaikum wa rahmatullahi wa barakatuh. Dr. Hamed Mohammed Almantheri.